the integral of t to the power of 2 times e to the power of t dt. So first of all, we see here we have t to the power of 2, and that's basically algebra. And e to the power of t is exponent. And the first circle at the top will be a u. So u is equal to the algebra one. So the algebra is t to the power of 2. We do the derivative. So du over dt is equal to 2 times t. So du will be equal to 2t times dt. And how about the dv? So we chose this to be u. And the rest, so dv will be equal to e to the power of t dt. And in order to find the v, you have to integrate. So we have the integral of e to the power of t dt, which is e to the power of t plus c. So our integral will be equal to u times v. So u is t to the power of 2 times v, which is e to the power of t, then minus the integral of v, right? So v is e to the power of t times du. So du is 2t dt. So let's go ahead and move the constant outside of the integral. To solve this integral, we have to use integration by parts again. So let's use the acronym LIATE. We have exponent. And then we have a t, which belongs to algebra. So this will be the u. So u1, let u1 equal to t. So du over dt is equal to 1. So du is equal to dt. How about dv? So we chose the t to be a u. So dv has to be e to the power of t dt. So v will be the integral of e to the power of t dt, which is e to the power of t plus c. This means that our integral e to the power of t times t dt is equal to what? We have u times v. So u is a t times v, which is e to the power of t, minus the integral of v, which is e to the power of t, times du. So du is just dt. So this is equal to t e to the power of t minus e to the power of t plus c. Now, we found out what this is, right? We found out what this integral is equal to. So let's go ahead and substitute this part into this part. And continuing on, we have t squared times e to the power of t minus 2 times t e to the power of t, 2 times e to the power of t plus, and that's all we have to do. So this here is the solution.